All right, guys. So today we are going to go over arrays. Some of you have used arrays before in different units for your own studies, but it's important that we go a little bit more in depth and we all make sure we know how to properly use them because they are going to be essential for your toolkit moving forward. So an array is essentially, for now, you can think of an array as a variable that can hold multiple values, right? So, for example, if you had a program which held the class averages for an entire class, you might have 30 students in that class, and you don't want to have a variable for every single student. Student 1, student 2, student 3, student 4. It would become excessive and it would become overly complicated for no reason. That is when you might have a single array which holds all 30 averages in one place. So an array is capable of holding many values, but its limitations are that they have to be the same data type, right? The array can only hold integers or the array can only hold strings, and you have to specify this at the very beginning when you create that array. So over here at the top of my code, I have a variable and I have an array. My variable sum is an integer, and I want to create an array that can also hold integers. Well, just like with the variable, when I created an array, I need to start by specifying the data type that this array will be. So this array can only hold integers. I then follow it with two square brackets, which tells Java I'm not creating your average primitive variable. I'm not just creating an integer variable. I'm creating an array that can hold integers. The name of this array, as specified after the data type, is numarray. I called it numarray because there really is no point to this array. It literally just holds numbers, and I'm using it as an example. But I do recommend that when you create your arrays, you create a name that has to do with the point of the array. And all of the values in your array should relate to a certain idea. Otherwise, there's no point in creating an array, right? If you create an array that holds both the temperature it is today and your average in a certain class, and your high score in a game you played last night, all of those numbers have nothing to do with each other. So there's really no point in holding them in array. All of the values should relate to the same idea. All right. So sorry, I went off on a tangent there for a second. You specify the data type followed by square brackets. You specify the name of the array. And then there are two ways to create an array, just like there are two ways to create a variable. You can either declare it or you can initialize it. In this example, we are initializing the array. We are starting it by holding the following values 4, 10, 4, 15, and 30. When you are initializing an array, you need to do so by specifying it with curly brackets. And then inside of those curly brackets, you need to write all of the contents separated by commas, another curly bracket to end, and then the semicolon. So essentially, what's happening here is we can imagine that we are creating a list, such as this over here. And in this list, we have 1, 2, 3, 4, 5 elements, we call them. Okay. Perfect. Excuse my poor drawing. So we decided to call this list numarray, and its contents are the numbers 4, 10, 4, 15, and 30. Okay. Now we actually have a way of labeling these elements through what we call an index. So we say that this array is length 1, 2, 3, 4, 5. It can hold up to 5 elements. Now, when you create an array, you are specifying its length right from the beginning, and you cannot exceed that length. I cannot fit 6, 7, 8, or any more elements into this array, because when I created it, I said it's going to hold 5 values. That is another limitation of arrays. You have to specify their size at the beginning, and you cannot exceed that size. Now, each element is correlated to a specific index. That is how you are going to be calling upon these elements by their labels, which are the indexes 0, 1, 2, 3, and 4, counting upwards. Now, it's important to remember that when you are counting the indexes in an array, you are always starting at 0, not 1. So this array is size 5, starting at index number 0 and ending at index number 4. Now, moving forward, I can access the length of the array within my code by calling upon numarray.length. Okay, so numarray.length is going to automatically calculate the length of the array, which is 5, and you're going to be using this to create loops and things of the sort. But for now, I am simply printing out the length of the array, which is 5. And if I run the code, perfect, the length of this array is 5. Now, if you want to call upon a specific element of the array, you do so by accessing it through its index. For example, if I want to access the very first element in spot 0, which is 4, what I'm going to do is print out the element in index 0 is, and then similarly to how you use the square brackets when you defined the array, you're going to do square brackets again after the name of the array, except inside of those square brackets is going to be the index number, and that is going to access the element itself. So as you can see, the element in index 0 is 4. We access that number 4 through this little line of code right here. We do the same thing with the number 15. We access the element in index number 3, 15, through numarray at index 3. Now, since these are integers, you can call upon them out of the array and you can actually do some math with them. So I take numarray at spot 0, which we already know is 4, and numarray at spot 3, which we already know is 15, and I'm going to add them together inside of a variable called sum, which can also hold integers, and then I will print out the sum of these two numbers, which is 19. Now that is the first way to create an array, and that is how you print out a specific element of that content of that array. Remember that we initialized up here. Okay? So what I'm going to do is I'm going to show you how to not initialize, but how to declare an array. So down here we have another array. This array is string type. It is an array because of those two square brackets, and I started it with Frodo, Sam, and Jimbo. So I am initializing it just like I initialized the other array. Now, let's say I didn't want to initialize it. Let's say I did not know what I wanted to start this array with. Well, what I might do is simply declare it instead of initializing it. So I do not have to specify right away. And if I want to declare okay, if I want to declare an array, it is going to look like this. So the exact first half begins the same, but on the right-hand side, instead of specifying what is inside of the array by initializing it, I am just saying I am creating a keyword new, which we will go much more into in the grade 12 course. But keyword new, I am creating a new string array that is size 3. So right now it's filled with nothing, right? If I try to print out the element, it'll say null because there is nothing in the array, but it is capable of holding up to 3 elements. So what we have here, shouldn't have erased that whole thing. I should have reused it, but oh well. So what we have through here is an array called name array. And since I declared it but not initialized it, I know that its size is 3, so I cannot hold any more than 3 values, but they're all null right now, right? There's nothing in them. So we have spot 0, index 1, and index 2 available to us. So what happens later is you can come along and you can fill these elements. So if I was to take name array at spot 0 and make it equal to Frodo, what I am doing is I am taking this and I am replacing it with Frodo. And I can do the exact same thing with spot 1 and spot 2 by taking name array at spot 1 and making it equal to Sam, and name array at spot 2 and making it equal to Jimbo. So you might ask yourself, why go through all the effort of writing 3 different lines for Frodo, Sam, and Jimbo, independently specifying each index, when I could have just done Frodo, Sam, and Jimbo and initialized it instead of declaring it? And you're absolutely correct. In this situation, if you already know what the contents of an array are, you should just be initializing it instead of declaring it. Oftentimes, when you are declaring instead of initializing, it's because you don't know what the contents of the array are going to be. So perhaps if I wanted to take the user input with a scanner, I would be allowing the user to input their own values for this array, as so. I should probably create the scanner. Give me 1 second. Okay, perfect. There we go. So now when I run this program, I didn't put a prompt for the user like I should have, but we all know, because I coded it, that at this point the user can input the 3 names. Okay, so first name Frodo, second name Benjo. I meant to type Benji, but we'll roll with it. Third name Roberto. And it's going to take that user input and it's going to fill the array with it. Okay. Now keep one more thing in mind. Let's say, so I created an array, it is size 3, and I allowed the user to input 3 names. And now I might print out something like the name in index 1 is plus name array at spot 1. So I'm going to print out whatever the user types second for the name. And then we're going to replace it. Okay, you can alter names within an array. So let's say that the user types in Frodo, Sam, and Jimbo. So let's replace this name, type a new one. Okay, so now we're going to take name array at spot 1, and we're going to replace it with, a new name. And we're going to say your name is now name array at spot 1. So this is another way that you can alter an array. You can take what was previously there and you can replace it with something new, or you can update it. So please input 3 names. Okay, we have Frodo, we have Sam, and we have Jimbo. The name in index 1 is Sam, makes sense. So let's replace this name by typing a new one. If I type in Roberto, what's going to happen is it's going to take Sam and it's going to replace it with Roberto, and Sam is lost. We can no longer access it, right? So make sure that you're being careful when you're altering your arrays. You can change different elements, but then you're going to be losing the old element that used to be there. Now let's talk about limitations of an array. This array is size 3, starting at index number 0, ending at index 2. Um, there will never be any negative indexes. There will never be any negative indexes. So as you can see, we'll always start at 0. If I try to access name array at -2, then it's going to give you an error that says not a statement. And if you try to run it, it'll warn you a second time, and it will give you this huge error down here that says uncompilable source code, not a statement. Okay? If you try to access another index that is above your maximum size, right? So this is an array of length 3, starting at index 0, ending at index 2. So one of the most common mistakes is that people assume because my array is length 3, I will have an index number 3. No, index number 3 is the first index that is a little bit too large. So if I try to access index number 3, it does not exist. There is nothing there. So you are going to get an array. You're going to get an array. You're going to get an error that says, again, not a statement. Okay? And the third thing that you should avoid, this one's not a super common issue, but obviously there are no decimals for indexes. Indexes are integers. They are whole numbers. So if you try to access 2.5, it's also not a statement. Okay? So those are the basics of arrays. I have another program here that I quickly want to show you. Oftentimes, you are going to want to print out the contents of an array. All right, so over here, I have an array called random array, and it is empty. It is fully null, but it is size 10, right? So what I'm going to do is I'm going to come back later and I'm going to fill this array. I'm just not going to fill it right now. If I wanted to print out all 10 elements in this array, you cannot do so by simply printing out the name of the array. That's one of the most common misconceptions, is that when you print out the name of the array, it will print out the contents to the screen. As you can see, when I print out the name of the array, ignore all these zeros. When I print out the name of the array, it actually gives me this, what seems like a random string of numbers and letters. It's not actually a random string of numbers and letters. This is what we call the memory address of your array. It's where it's being held inside of your memory. And we will go into more detail about this in grade 12. The point is that you cannot print the contents of an array by calling upon the name of the array. What you have to do instead to print out the entire contents of an array is you have to create a for loop that accesses each element individually. And this is where the name of the array .length is going to come into handy. So I create a for loop starting at I equals 0 and going until I equals 9, because 9 is going to be the largest index in an array of size 10, right, from 0 to 9. So how do I create an array? How do I create a for loop that goes from 0 to 9? Sure, I could do this and it would be nice and easy, but this is not efficient code, because then if I decide that I want my array to be size 100, this for loop is still going from 0 to 9 when I want it to go from 0 to 99. So instead of 10, I'm going to use random array.length, which is going to be 10 because the length of the array is 10, but now my program is more automated and much, much more efficient. So I have a for loop that is going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And for each iteration of this for loop, I am simply going to print out the element in index number I, which will be each element. So you can see that's what this list is over here. I declared an array, but I haven't done anything with it yet. So it's just going to be filled with all zeros, right? It's going to automatically set each number to 0 for me because I haven't filled any of them in yet. Okay, before it was null, that's because we were dealing with strings. It automatically sets strings to null, that's their default value, and it will automatically set integers to 0. So let's actually place something inside of this array. I create another for loop that, again, is going to run 10 times, one time for each element of the array. And for each iteration, I am taking the element in index I, and I am going to be placing a random number between 1 and 100. Okay. And what I am doing is as I go along and as I place a random number in each element, I am taking that same random number that is in spot I, and I am adding it to the sum. So I keep adding up the sum for every random number that I create. Okay, so I print out the array, which is all zeros, and then I fill the array with random numbers between 1 and 100, each time adding that number to a total sum. I then make a third for loop that does the exact same thing as the second one. It simply runs through the length of the array, printing out every number, but this time the numbers aren't going to be all zeros. They're going to be these random numbers that we created, and this is our first time seeing them. And at the end, I am going to print out the average. The average of these numbers is the sum, the total amount, divided by the amount of numbers we added up. So, which would be 10, right? We added up 10 random numbers over here. We're dividing it by 10 to find the average. So if I run this program, here is when I printed out the memory address by printing out the name. Here is the first for loop that printed out the contents, all zeros. And then I had a second internal for loop that created random numbers and added the sum. These are the random numbers I created. And using that sum, the average is 36. Now, because I used random array.length and I automated it, if I wanted to, let's say, change this size to 20, all that I have to do is change that number to 20, and the rest of my code will automatically adjust to fit this scenario, right? As you can see, I am printing out 20 zeros here. I have 20 random numbers here, and the average of these numbers is 52. And as you may know from math, empirical data becomes more accurate as you have more data. So we all know that if I pick a number between 1 and 100, my average should be around 50. Now, that doesn't always play out. For example, if I only have 5 numbers, my average would be 45, 35, right? Not very close to 50, 39, 56, 52, 79. That was way off. 83 is way, way off. So even though my average between 1 and 100 should be around 50, this is way off because I don't have enough data. If I was to change to have 100 sets of data instead of 5, and I was taking the average of 100, you'll see that the average is always much closer to 50, right? I have never gone below 40 and I've never gone below 60. Okay, and this will be an interesting test of that. And the larger, so right now we have 100 pieces of data, and the larger your data set, let's go to 1000, the larger the amount of empirical data, the more accurate your result will be. Over here, the average of 1000 random numbers is 50, 50, 50, 50, 51, right? Which is an interesting thing that we can test using this program. And oftentimes, coding is used hand in hand with mathematics to prove, especially once you get into higher levels, you use coding to prove different theorems that you can't prove without the use of computers, because they obviously work much faster than our brains do, right? I couldn't average 1000 numbers as fast as this program is. Okay, so that's all for today. I know it was a longer lesson, but the first lessons in every unit usually are. Make sure you're doing your homework, and please let me know if you have any questions.